Good morning, everyone. This is Greg, and we are talking about eddc608 week 4. This is our fourth video in the series. And the primary topic for this week is the one-sample t-test. Now, there's a big difference between a one-sample t-test and a two-sample t-test. So we're going to go over them. There's some references in your book on page 309, and the book goes in to a rather detailed explanation. I'm going to try and make it a little simpler for you. So here's how a one-sample t-test works. We're going to do two examples. Okay, first of all, let's say that it's commonly believed that the mean length of the cat's tails in the state of Oregon is, let's say 10 inches. So that is what we would call our null hypothesis. HO is that the cat's tails, the mean length of a cat's tail in Oregon is 10 inches. That's the mean. And you as a researcher seem to think that it's probably either shorter or longer. So our alternative, or our research hypothesis, would be that it is not 10 inches. It is not 10 inches. So there's our research hypothesis. Now, how do we conduct the one-sample t-test? Well, first of all, let's say we take a sample of cats. So we get 15 cats. So we have an N of 15 in our sample. And we add up all the cat's tails, and we get a mean length, a sample mean of 14. And we also have to know the standard deviation of the sample. The standard deviation of the sample. Now, let's say that that's 2. Now, remember, from the first week, there is a good calculator in which you can put in a whole bunch of values, and it will give you a mean and a sample standard deviation. So you'll have to use that. So if you were pulling out the raw sample data and you had 15 pieces, you would have to find the mean and the standard deviation. So I'm assuming that our mean is 14. Now, how do we conduct the test? Well, the first thing we're going to do is use the calculator specified in your course content called the one-sample t-test. And I have it right here on my laptop. I'm going to show it to you. This is what you should be looking at. The one-sample t-test. And that's the calculator we're going to use. Now, how does it work? If you look at the right side of the screen, you see what is called the hypothetical mean value. Well, that is the value for the null hypothesis. So I'm going to go to the calculator, and I'm going to put 10 in the blank where it says the hypothesized value. Now I'm going to go over to the left, and you'll see a place where it says enter mean, SD, and N. So we have to enter these three values in those fields. So I'm going to put a mean of 14. I'm going to put a standard deviation of 2. And I'm going to put an N of 15 in. And that's all I have to do. And then I'm going to click calculate. Okay? And when I click calculate, it gives me a two-tailed p-value of 0.0001. Yes, I got that right. Now, what does that mean? Well, as you've learned in hypothesis testing, if the p-value is less than the specified alpha, and alphas are your minimum probability of committing a type 1 error. They can be set at various levels, but primarily in research, our alpha is set at 0.05. So we came up with a p-value of 0.001, which is obviously less than 0.05. Now, what can we conclude from that? We can then make a statement and say that we reject the null hypothesis that the mean length of cattails is 10 in favor of the alternative hypothesis, which is that the mean length of cattails in the population is not 10. Now, with an alternative hypothesis, we can never confirm it. All the alternative hypothesis does is shed doubt on the null hypothesis. So we make the statement that we have evidence to reject the null hypothesis that the mean length of the cattails is 10 in favor of the alternative that it is not 10. And as a researcher, that's all we can do. Now, what affects this p-value? So for instance, if we had a p-value of 0.0, say we had a p-value of 0.07, that would not be smaller than 0.05. As a result, we could not reject the null hypothesis that the mean length of the cat's tail was 10. Now, how would that come about? Well, it depends on the properties of the sample. So, for instance, let's keep our original values and let's make our sample mean only 11. Let's change this to 11 in the calculator. So I'm going to go do that. And wow, that worked out pretty well. When I changed the mean to 11, which is quite a bit closer to 10, I actually did get a p-value of 0.0733. As a result, in this case, I cannot reject the null hypothesis because the p-value is larger than the alpha. Now, one of the most common mistakes made when people study statistics is to assume that the difference between the sample mean and the hypothesized mean is what determines whether you can reject the null hypothesis or not. This is categorically not true. These three numbers, the size of the sample mean, and the sample standard deviation, all combine to create a number called a test statistic. And that test statistic has to differ enough from the hypothesized mean to reject it or not. So, just because we changed the sample mean to 11 and then rejected the null hypothesis doesn't mean we could have left it at the original value. And if we would have reduced our sample size or increased our sample size, or if we would have had a larger or smaller standard deviation of the sample, they would have all combined to tell us whether we could reject the null hypothesis or not. Now, the mathematics behind that's rather elaborate, and we don't do that in this course. We want to teach you how to use the one sample t-test calculator to reject your null hypothesis or not, and that's what most researchers do. We will provide some explanation as to why that works also. Okay, so there's one example. Now,